Hi, in this video I'm going to introduce character and string data types in MATLAB. So I want to start off with a brief introduction looking at the graphic of all the MATLAB classes or data types. And we have logical, and these are arrays, right, or matrices, so matrix or array. We have a logical type, strings, characters, numeric, tables, cells, structures, and then kind of a special class here, scalar function handles. So what is a string and what is a character, right? Well, these are data types used in MATLAB to represent text. Letters, sentences, and they can be numbers and they can be letters. They're stored off as numerical values but representative text in the MATLAB language. So we store a 1 by n sequence of characters, in this case characters meaning alphabetic characters, a space can be a character, multiple spaces can be a character, commas, symbols, numerical values as generic, let's say, as characters or string data types. I'm going to start off by using strings. And the most direct way is using double quotations. So if you create an assignment statement as shown here in MATLAB, S is assigned a value of double quotes, hello, comma, world. This stores the character array, hello, world, to the variable S. So for example, here's the output that would be echoed to the screen, hello world, and it's returned within the double quotations. And so I use the length function, so length of S, and the string has a length of 1. So there's a new function or function in MATLAB called strLength, string length. So if you look at the string length, use the string length function, we have a value of 12, right, for the default variable ANS. So that 12 corresponds to the 12 characters in hello world, including the comma and the space between hello and world. So if double quotes are the character operators, if you will, to create a string, and we're talking about using text as a string, it's conceivable that maybe the text would use double quotes. So how do we handle double quotes within the text array? So for example, I have a sentence here, a grammatical sentence. They said, comma, quote, welcome, close quote, and waved. So if we want to make this a string array in MATLAB, I just said we're going to open and close it within double quotes. But if you think about it, we're going to say double quotes, they said, comma, then we got another double quotes, welcome, exclamation, double quotes, and waved, period, double quotes. It'll give us an error. We don't have equally matched quotes because the double quotes of the grammatical around welcome won't compile correctly within our double quotes. So how are we going to do this so the double quotes around welcome are not quote unquote string operators? And in this case, what we'll do is use two double quotes around welcome. So now all those words that I was saying now made a little bit more sense graphically here. We see we open up the double quotes for the string array. Continue with they said. Now I use two double quotes, closing welcome, and then close the string array with the double quotes again. And what happens in MATLAB when you execute that statement? We have a string array, and it includes some symbols and characters, alphabetic characters, a comma, exclamation mark, and two double quotations around welcome. Another interesting operator with strings is using the plus operator. So we want to add text to the end of a string. I want to highlight the fact that the plus operator also can convert a variable to a string, or specifically the value assigned to the variable to the string. So typically we assign a number to a variable, and so that number will be converted to a string and augmented or appended to the string that we're operating on. Yes, that's fine, right? So I just have a few lines of code here to calculate the Celsius temperature of the variable Fahrenheit, which has assigned a value of 71. So Celsius is the variable and has a value of 21.667. So I go ahead and create a string by opening with double quotes. I have the text temperature is, and there's two spaces in there, so I close with the double quotes. Now I'm using the plus operator. Now Celsius is a variable, so I'm not using the double quotes. If I'd use the double quotes, then Celsius would become a character array. But we want to convert the value assigned to the variable Celsius. And now we want to append uppercase C. When we execute this line of code, it returns temp text is equal to temperature is 21.667 C. So if you're familiar with fprintf or sprintf, you can see this is kind of a very similar result, and a little bit more clear or easier way to create this string array if you want to create strings with numerical values from your calculation. So you can imagine if this was in your program, if the value of temperature changes every time you'd run this, then the text string, if this was displayed or written to a file or displayed to the terminal, it would update automatically the temperature is given a current temperature C. Now if you think back, what I just said is to append, right? If you weren't doing a conversion, you could just use the plus and then the C string, and it would append to the first part of the string array. And that leads us to a function introduced in 2019a version of MATLAB, the append function. So I'm creating a new assignment statement. Temp text2 is assigned append. I'm calling the function with parentheses, passing in two input arguments. The first input argument is a direct string array, today, today's, and we want to append today's with temp text. So temp text still is in memory from the previous assignment statement that we augmented with the plus operator, right? So temp text2 becomes today's temperature is 21.667 C. So take a moment and think about this, right? Are you happy with that format? You may want to include a space after 21.667 in between the number and C. Think about how would you do that? How would you include a space between C? As I mentioned, the comparison between fprintf and sprintf. In this case, we're limited to the default precision. In this case, 21. The 4 decimal points of precision is the short format. In MATLAB, you can go longer or use bank. If you wanted to have less decimal precisions, what functions would you use to calculate and reduce the number of precisions? Maybe round, floor, ceiling, something to that effect. So having talked about strings and characters after in the first slide of introduction, right? Now, string was a data type, but now there's also a string function. So the string function converts different types or different classes of data, say numeric, date, time, duration, and categorical values, to strings. An example, I'll just show a conversion of the output of pi. So pi is the MATLAB constant to a string. So PS assigned to a string, calling the string function, passing in the input argument pi, and now notice 3.1416 is enclosed in double quotations. PS is a string. It is no longer a numerical value. If you have access to your MATLAB program and you type this in and check your workspace and look at the type in the workspace, you'll see that PS is a string and not a numerical value. So in this case, the numbers in the decimal place are all characters in the string array. So the terminology of array is the same as this for numerical data types, right? Up to now, I was using string as a sequence of characters. Now this, and more specific, it may be you may think of it as a matrix, but it's a 2x2 string array So I'm creating the array using square brackets as you would with a numerical data type if you're creating a matrix. So we have each word or sequence of characters closed in double quotes, comma, and a new line, semicolon. I'm using ellipse for continuation of a long command, long expression, and using the raccoon and the scientific name, and possum, the scientific name, and a little bit of, I guess, Latin, right? So now, when you execute that expression, str is now assigned to a 2x2 string array. So it looks exactly like a matrix, but different, right? And if I use the string length function, I do see that we have 4 elements in the 2x2. The first element has 7 characters, right? 1, 2, 3, 4, 5, 6, 7. And 13, 6, and 16. So you should be able to visualize these elements in terms of indexing if you want to access or modify these, right? Row 1, column 1, row 1, column 2, row 2, column 1, and row 2, column 2. So in 2018, MATLAB and MATLAB products all support string array data type. So that means functions that were previously written for character arrays now also accept the string data type. So there were some, if there are functions that had input arguments of characters, character arrays, they're interchangeable with the string arrays. And one that comes to mind, again, I'll mention the, say, the fprintf. If you look at some of the earlier documentation or some earlier code that may have been written prior to before 2018, you would see that it was character arrays within the sprintf function. But now, if you're going to use, in the current time, 2019 or 2020, you can use fprintf either character arrays or strings, string arrays. So you have to experiment and get acclimated to that. If you look at some of the help function, or if you're looking at some code that was generated prior to that, and you may inadvertently try strings and expect an error, then you'll be might be surprised to notice that there was no error. That's because the functions were updated to accept both characters and string arrays. So that transition leads to what is a character, a char? This was the initial data type in MATLAB for texts in the MATLAB code. You see the main difference between the string and the character, if you create them directly, is to create a char or character data type, you use single quotes instead of the double quotes. But the big difference is the size, right? So I created hello world with the comma, same thing. Remember last time when we used length, it was 1. Now if we take a look at, say, use whose char, CHR, as the variable that I use in the assignment statement, size is 1 by 12 for each of the characters in hello world, including the comma and the space. And it tells us the class is char and the number of bytes used for that assigned to the variable CHR. So the character array includes within the size each element of the character in between single quotes. So H is an element, E is an element, L, O, and comma, and the blank, the white space, if you will, and so on, are each element. So the character data type, or char, has a size 1 by 12. As to compare it, if you think about it, if you take a minute to think about it, is the string data type. This had the length of 1, or the size of 1. See subsequently how that may affect your coding. I just want to highlight too, we have the same situation with the double quotes and the single quotes, right? Going back to our sentence, our grammatical sentence, we want to make a character type. We're going to use 2 single quotes to have a quote around welcome. Now, something I didn't tell you, because I want you to figure this out for yourself. The spacing between the 2 quotes, the 2 single quotes, or the 2 double quotes, is very important. If you include spaces, a space between the double quotes or a space between the single quotes, you will get an error. And it'll take some time and repetition to get acclimated to the fact, do you include a space or you don't include a space? Because when you're typing in a MATLAB in your program, when you type in 2 double quotes without a space, it's kind of difficult to read because you have these 4 little tick marks all in a row. So you try it and practice it. You'll come to terms with it. But if all else fails, if you do it the wrong way, MATLAB will be sure to tell you with the red errors, right? It's just going to take some time and practice. So why use char? In one regard, it can be very useful to specify single pieces of text like file names. And the MATLAB documentation also include the plot labels. So, but I think the main reason might be, or what I use it for is, if I use the difference between chars and strings, I'll select a char data type if I need to access the individual characters. Remember I said, I made a big deal about it. The char was 1 by 12 on the size. In the string, if it's a size 1, if you need to do some text manipulation, or if you need something, for example, in your code to analyze the text, you could do it more directly with a char, because the char array, each element represents a character. So for example, I have name Bevan. If I want to access the first 3 letters, I could just simply use the vector 1, 3 as if it was a numerical array, and I'd return BEV. So think about, you've seen emails with names and number appended to them, or you might say if a email names are too long, they might have some ISP or domain providers might take 5 letters. So they take the user's name, truncated, access the first 5 letters, create the user ID or the email name. Well, in this case, chars would be an ideal example, ideal data type to use, because you could easily access and manipulate each individual element. Now for chars for concatenating pending, it's not much different. Using single quotes for each character array, and then I can concatenate them using square brackets, just like a numerical array, or I could use the append function, or pass in the arguments for the 2 character arrays I want to append. So here's an exercise you can work on, right? Remember I said previously that all the MATLAB functions supported character data types and string data types. What happens if you passed append and one input argument was a character data type and another input argument was a string data type? Will it execute or not? Will it give an error? Take some time to try that. I mean, it said all functions support both characters. One thing you do is look up the help for append and look at the syntax example, the syntax versions, and look at some examples. Or you could just throw caution to the wind and try it. By passing in a string and a character and see if it appends, and if it appends, is the string converted to a character or the character converted to a string? If we go back to the string function, how do we convert characters to strings, right? So we have a character array. It's enclosed in single quotes, greetings, friend. And we could use the string function to simply convert to a string. So depending upon the previous exercise I just mentioned, maybe you could pass in, if you needed to do a character to append, right, you could use the string function as the input argument around the character array. The string function also converts numerical values to strings, right? So I have a numerical array. Just to keep things interesting, I use the constant pi. Don't look at it too quickly and say, well, pi is a character, or pi is a string. No, pi is a constant in MATLAB. So they're all numerical values. And if I pass the x variable into the string function returns a string for each element of the numerical array. I know you immediately thought, why'd that happen, right? Because strings was the size of 1. So this is an example of understanding what the MATLAB functions do and how they perform. The string function does not append or concatenate all of the strings. It returns individual string array for each element. So the first element, you did a string length, right? It's going to be 1. The second element is going to be a string length of 2, and then a string length of 1, 2, 3, 4, 5, 6, 7 for the fourth element, right? So there are 4 individual string arrays that have a size 1, and if you did the string length, it'll tell you how many elements are in, how many characters are in each element. If you refer back to the slide number 1, I did mention some function, some data types, right? So we have a datetime class or a data type. It's useful in MATLAB that you can do some calendar calculations between days and months. It's really pretty interesting and very useful. And so the datetime function has some, I encourage you to look it up for the help pages. If you want to see a date time now, it returns the value by default, and there's different syntax versions how you could specify what you want to see in the date time. But again, if we use an example of the string function, it will convert the datetime class to a string class. Again, this will be useful for printing text files or documents. So remember, we had an empty array for numerical arrays. We just created that by using square brackets with nothing in it. So if we had a assignment statement, x is equal to square brackets, an empty array. We have something interesting with strings, right? We have empty and missing strings. So what does that mean? An empty string has 0 characters, okay? So you could create an empty string by calling the string function without input. Remember, when you call a function in MATLAB, some functions do not return values, and some functions have syntax that you can call the function without any inputs. Well, string is a function that you could actually call without any input. If there's no inputs passed to the string function, it creates a empty string, and it just returns symbolically double quotes with nothing in between. You can do the same with char. I tried, right? If you just say C, assignment statement C is equal to char, so char without any input arguments returns a 0 by 0 empty character array. So excuse me. What do we want to create an empty string array? Remember I said call string without any input functions, right? So look, if we have an assignment statement, str is equal to strings 3 by 4. We have a 3 by 4 string array of nothing. It's a string about nothing. Sounds like Seinfeld. But pay attention, right? I'm sure you read right to the bottom here at the big red strings. This is another function. It's not the string function, it's a strings function. Strings function. Again, I encourage you to look up in the help pages and familiar yourself with details of string and strings, string and string functions, string function and strings. What is missing? Well, let's create a little example here, creating directly a variable str is an array, and it's a string array. So the first element, str1, is an empty string because I use double quotes with nothing in it, so that's empty, right? The second element is moon within double quotes. The third element is the string function with the variable missing. So not strings, but the string function with the variable missing is the input argument. I should mention the input argument. If we execute that, what do we get? We see str is a 1 by 3 array, 1 row by 3 elements, if you will, of an empty string array, the moon string, and then we see missing within the arrow less than, or it's not less than, but the symbols less than, greater than signs, right? Missing. Why is this useful? Good question. Think back to our logical or relational expressions, right? So there is a function MATLAB calls is missing, right? So missing is this placekeeper, right? So we use this term string, the variable string rather. It's a 1 by 3 array, an empty array, empty string. then we have the moon string, and then we have a missing string. And so is missing str. So we have a relational array. It says 0, 0, 1. So it means false, false, true, right? So out of the three elements, the first two elements are not missing. The third element is missing because it's true. So now, this allows you, say within your algorithm, if you need to do some string manipulation and comparing, and what might this be is some user ID information. It might be a name and an email address, first name, last name, email address. Well, if one of those three elements were missing, if you're missing the first name, last name, or you're missing the email, well, now during your data processing, now you could use the isMissing function and determine if you had a valid user registration that had all of the data not missing. If someone was missing data, well, you could flush it out and send them a message or not include them into your calculations, whatever your algorithm might be. However, there's some interesting aspect to it. You compare a missing string to another string, the result is always false. That's kind of doesn't sit very well at first thought, right? Even if you compare a missing string with another missing string. So let's take a look at some of what does that mean, right? So if we stop and think about it, if you imagine, say, if you compared a non-missing string to a missing string, it's logical false, right? Because one is not missing and one is a valid string. So correct, that would be false. But if you compare two missing strings, that's also false. Voltage spark there for some reason. So now this is our relational expression, right? We have a variable str that's assigned to string missing. Now we want to compare str to a string. We know str is missing. And I encourage you to try this, and I terminated it with a semicolon so I wouldn't reveal the answers, right? So you should try this. So yes, this is missing. str is missing. Is missing equal to, remember, this is an assignment operator. This is an assignment operator. Two of these symbols, two equal signs, or equal logically. Is str equal to voltage? Well, it's reasonable to say no, because missing is not the same as voltage. However, str is still missing from the assignment statement. Is str equal to string missing? I would have said, if I had taken a guess here, I would have said yes, right? Missing equal missing. That's not the case. It's always false. str missing is not equal to missing. So keep that in mind if you need to do some relational expression testing for missing, as I described previously. If you have an array of values and you need to find out if something's missing or not, you have to add another step, right? You have 0, 0, 1. So maybe you have a key and say, you know, the 0, 0, 1 equal to 0, 0, 0, 0, 0, or 1, 1, 1, or whatever field you want to compare bitwise. But you cannot compare two missing strings and expect to get a true value. In MATLAB, if you compare two missing strings, they're always false. Now, accessing elements follows the same procedures as indexing numerical arrays. Back to our string with our raccoons and possums. It's a 2x2 string array. Remember, this string array, this terminology means each element is a string of size 1. But it's an array, so we have 4 elements. And the 4 elements are arranged into a 2x2 array. You could arrange them into a 1x4 or a 4x1, same as numerical formatting. But in this case, I'll highlight, I use the semicolon. So I have element 1, element 2, semicolon, element 3, element 4. Row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2, and our 2x2 string array. So there shouldn't be any surprises there, same as our numerical array, but each element now is a string data type. I'll mention, I'll leave it to you, experiment. Can you do this for char data types? Can you do this? Can you create a 2x2 string character array using char data types? Remember, char data types is the single quotes. Succinct answer is yes and no. Yes if you're creative, no if you're not creative. So I'll leave that as an exercise for you to think about and try it, right? I'll tell you, if you start off and just using with single letters of the alphabet, A, B, C, D. Made an A, B, C, D and arrange it into a 2x2 character array. Is it compute or not compute? Then try A, B, C, D. In other words, the first element has 2 characters, and the second, third, and fourth element only has 1 character. So, that's for you to think about. If you want to access the first row of the 2x2 string, just use our array indexing concepts right. Remember, rows and columns, the ordered pairs, rows and columns. The colon is the operator for all the columns. First row, all the columns, has returned raccoon. And Procyon loader. If you only want a particular element, in this case, the second row, second column, Landry formies. So indexing is exactly the same as the numerical indexing properties. Not a problem. Again, keep in mind, I'll ask you, right? What's the length of each element of the string array? 1. You use str length If I use str length of str 2 by 2, you would get how many characters are in fourth element. Another question to think about, how would you do linear indexing on this array, right? What if you wanted if you wanted to use the single index number, the single subscript, if you will. So str3, is it going to be 1, 2, 3 or 1, 2, 3? The Procyon loader or possum? Is str3 will return the value of possum or return the value of Procyon loader? 1 and 4 is easy, right? 2 and 3 is the interesting ones. So here's something interesting. We've seen the same thing in numerical arrays. Just using the previous string, right? str 2 by 2. We're using a size function. I didn't assign any output arguments, but we saw it was a 2 by 2 on a previous page, so this is 2 rows and 2 columns. So instead of accessing the elements of the string array, I want to assign a new element. So the size is 2 rows by 2 columns, but look what I'm doing here. I'm saying the third element in the fourth column is equal to dog. So what MATLAB will do for you, whether it's expected or unexpectedly, it will increase the size from 2 by 2 to 3 by 4, and look what it does. It fills up all the missing information with the missings. So here's our original string array, the 2 by 2, raccoon and possum, and their scientific names. I created an assignment statement and said the third row by fourth column is equal to dog, which is down here. So everything else was padded, if you will, or assigned to missing elements in the array. So think about that. Hopefully the light went on here, right? So what's the difference between, if we go back and say we had empty and missing, empty and missing. Empty array had nothing, missing was its own special element value, if you will. So now if you had to do some manipulation on it, if you did some relational testing, it may be a little bit more convenient now. It may make some sense. This may have some usefulness in your programming to jump or to increase the size. Because maybe you know that in your algorithm that based on a calculation or result that there's some element or the size of the array is going to grow, and then you might have to go back and backfill the information, or what's missing is not important. The only thing that's important is the new information that you need. So it's a real convenient way within MATLAB that you don't have to go back and reinitialize or create new arrays based on unexpected result in the increasing of the size of the string array. And along with, there's some interesting MATLAB functions, right? Is space. It's another relational function. We're passing in a string array, and now what are we doing? It's telling us, even though the string array is a length of 1, the isSpace function parses or breaks it down into the individual characters. Now you know they could further do some processing and say, yes, the fourth element in the array is a space. Some of the other is functions, I just kind of terminated them or highlighted them here. Is right. Is char, is string, is letter. So yeah, I confused myself there, right? Because I forgot about the white space. I saw 3 numbers and I had 4 zeros. Where did the 4th zero come from? Well, there's a space there. 1, 2, 3 space. It's not letters. The only letter is A. So you can imagine any other character in there that's non-alphabetic is going to be false or zeros. You may see some of these things in the literature is referred as masking or bitwise. So if you're looking for all the numbers or all the letters, or maybe they're not a simple sequence as this, that may be, letter, number, number, letter, letter, number. Well, then you would have the logical result of 1001. Now you can go back and manipulate and access, like we did relational indexing, and retrieve all the letters or all the numbers, whatever you're interested in. Is numeric as the converse of is letter, right? So now if you did is letter, is numeric, if now what's left is symbols. Maybe you're looking for the @ symbol in email, and some names have letters with numbers appended to them, and then you had the @ symbol in email. So if it's not a number, it's not a letter, then it would be the @ symbol. It may be tested afterward to see if it is valid. Maybe somebody typed in the wrong symbol for the @ and then you would flash back and say invalid email address. So the whole point is, within strings and characters, you could still do a lot of the algorithm development and computation and testing and comparing and evaluating character strings, and meaning characters are text, text with symbols and numbers. Strip. The strip is an interesting function. It strips off beginning and end spaces. Has some syntax version. You could strip to the left, strip to the right, or both left and right. Maybe you need spaces on the beginning or at the end. All depends, right? New line. New line is a new function recently added to MATLAB. So we're back using the plus operator. We have a string array. Xanadu did Kubla Khan. Plus, new line, plus, and then a second array. So we know we're doing some appending, but what does new line do? Well, believe it or not, it makes a new line, right? And if you're thinking about it and you're familiar with fprintf and sprintf, that's the \n for new line. You can hopefully see some similarities here with these functions and string manipulations. A bit more direct than the fprintf. So here's an online exercise you could try and experiment with what's happening. Feel free to pause if I go too fast, right? A character arrays, so square brackets. So we have new lines, right? Is this going to be 1, 2, 3, 4, 5, 1 by 5, 5 by 1? Can be 2 by 3. Can, has to be the 1 by 5 or 5 by 1 rows or column array, right? Another assignment, last name. So presumably it's Mary Jones, John Adams, Elizabeth Young, Paul Burns, and Ann Spencer. What you want to do, you try this, but I'll tell you what the objective is, right? You want to combine these two string arrays and add a space between them. We're using a plus operator. We have a string array plus string array plus string array. So try that on your own and experiment with it and see what happens. Because you can have a whole lot more fun with it, right? More functions. I bet you thought when we started is, what can you do with strings and text and characters, right? Question is, what can't you do? It's the limits of your imagination, right? So, believe it or not, it does say a rich set of functions because MATLAB can be, you take for the quality that for the product, and have a vast array of functions, including split, join, and sort. Well, sort is pretty cool, right? And manipulation and rearrange string arrays so that rearrange the string arrays, the names would be in alphabetical order by last name for the sorting, right? So we go back to the example completed so far, right? Names is a column vector, 5 rows with 1 column. This is a little bit different. If you go back, we had your online assignment had two string arrays. This one is 1 string array: Mary Jones, John Adams, Elizabeth Young, Paul Burns, and Ann Spencer. 5 rows by 1 column. We want to split them. What does that mean? Without looking at the help function, I mean, it could split them into 5 elements, right? It could be 10 elements. Well, what it does, so we're splitting names. And now remember, we went from 5 by 1, so now we're going 5 by 2. So now we have an array, 5 rows, column 1, column 2. And the reason we split them is because now we want to manipulate them, right? We want to reverse the order, put last name first, and add a comma after the last name. So if we take a two-step approach, right? So reassign names. We don't want to create any new variables. We have reassign variable names using assignment statement to names. We're indexing all of the rows of the second column and appending all of the rows of the first column. So second column first, first column last, right? So we swap the order. And then, we don't see I terminated with a semicolon, so I'm again encourage you to try this on your own and verify this. Now the first column, I want to modify the first column only. I'm reassigning this, right? Names, first column is equal to names, first column, back to our plus operator, plus comma, right? This is a character. I'm just giving you a minute to, gather your composure here, right? Because look what I'm doing. And this goes back to the statement we said earlier is MATLAB product support, MATLAB function support strings and characters. So this was all string array, but look, I'm adding the character to the strings. Character is a comma. It's a character because I got single quotes. So I encourage you to verify this and try it with double quotes, add to the strings or add to character. I think you'll find that the plus operator works for both strings and characters as if it were a function because it is performing an operation. So that's interesting, right? So names, all the rows of the first column plus a character. So I mean this is 5 by 1 and the plus operator is adding one comma, but then again to the complete every single row. Then now to put things back to where they were, we could join them. So now we're back to a 5 by 1 string array. The modification, the manipulation was performed here, right, without mentioning what the algorithm was up front. We had a 5 by 1 string array of first name space last name for each element. 5 elements, right? We split them, we swapped them, we appended a comma to the first column. Now we join them back together. We have 5 by 1, last name comma first, last name comma first. Go, right? Now I'll tell you, you're probably wondering what happened to Char, right? I've probably had one slide at the most on Chars. And I said the primary attribute of a char was if I needed to manipulate and access the elements of the character array were easily accessed, right? Because each character had 1 by n sequence, and I could index to whatever I wanted to do or modify any one of the elements. That's right. If you start making, and I alluded to this in one of the online questions, right? If you start try to make character arrays, it becomes a little bit more cumbersome because, as I mentioned, if you have one character that has 2 elements and another character array that has 1 element, and you try to make that 2 rows by 1 column, MATLAB's not going to be happy because first one is 1 by 2, the second one is 1 by 1, right? And all the rows have to have the same number of columns, and all the columns have the number of rows. So that means make the dimensions compatible, each of your character arrays are going to have the same number of elements. Column array, column vector, if you will, column array. So for example, right, if you try to make just this first column, 5 by 1, Mary, John, Elizabeth, Paul, and 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, right? If these were character arrays, they would all have to have the maximum number of elements, 1, 2, 3, 4, 5, 6, 7, 8. We would have to append spaces to Mary, another 4 spaces, John another 4 spaces, Anne another 5 spaces, Paul another 4 spaces, because 1 by 4, 1 by 4, 1 by 8 won't fall into an array because they have different column sizes, if you will. So I encourage you to experiment that on your own and verify that you will not be able to create a character array as simply as a string array. And that all goes back to the size. The string has size 1 by 1, or length 1 by length of 1. So that's the advantage of the string data type, right? No matter how many elements you have in the string, the length is 1. If the length is 1, you could have as an element array effortlessly. Character 1 by number of elements. So for years before they entered string array, the programmer was burdened with a lot more effort, if you will, to make sure all the dimensions of the character arrays were compatible to make character array if you needed to make an n by n character array. It's possible, it's just a little bit more work for the programmer. Sort, and that's all we have for strings and characters. I hope that clarified data types of strings and characters and showed some examples and function to use. Thank you.